Hi folks, it's time to talk a little bit about rock deformation. And I've kind of been putting this back a little bit because I wanted to get the hydrology component done before we talked about this. But I'm kind of teetering, whether I need to do the petroleum first because it's kind of related to the hydrology, or should we do rock deformation? So I've gone ahead and decided I'm going to go ahead and complete this part anyway of doing rock deformation. Now, many of you already have an idea what it means to travel down a highway going a certain velocity. So velocity is related to distance, right? And so it is a distance over a given period of time. And so oftentimes we refer to it as miles per hour or kilometers per second or something like that. Those are all velocities. Now, you don't start out, if you're going down the highway, you're going 70 miles an hour, let's say. If you're going 70 miles an hour, you don't start at 70 miles an hour. You have to start at 0, right? And so you get in the car and you start driving, and then you step on the accelerator. So the accelerator is going to get you up to that velocity of 70 miles per hour. When you go 70 miles per hour, you're traveling pretty fast, and your car weighs a little bit, right? And so it actually has a mass, and you have a mass as well. So as you're traveling down a highway, an acceleration is going to change. It's going to be a distance times time times time. And so it's going to be dt squared then, okay? So this is going to be a squared unit then. And so that's equal to acceleration. We use a little a to indicate that. So one of the most fundamental concepts in all of physics is that sometimes we apply forces to things. That's what happens when you crash your car, let's say. Let's say a tree jumps out in front of your car. You were going 70 miles per hour. You have a certain deceleration then if you all of a sudden stop your car, go 0 miles an hour when you hit the tree. And so one of those fundamental concepts is that force is equal to mass times acceleration. Okay, so it was actually Newton who came up with this law here. And so with force is equal to mass times acceleration, the mass is going to be your automobile, and you're going to be going 70 all the way down to 0 again. So you're applying a force. And you can think about this, that force right there is going to be applied in a certain area, if you will. It's going to apply to the front of your car, and it's going to apply to the tree as well. And so when we have a force applied to an area, we refer to that by a new symbol here. I'm going to turn it around backwards. It's this little sigma, actually, and so here, let me try to do it a little bit better. That's the sigma right there, is equal to force applied to an area. So when we do that, that is equivalent, that's what we call stress. It is equivalent to something we also call pressure. And so if you can apply pressure to something, you're pushing against it. You're applying a force against a certain cross-sectional area. So stress can lead to strain. And so we're going to take a look at that a little bit. First of all, I need to tell you a little bit about the different kinds of stress. And so first of all, you can have compression. One variety of pressure or stress that you can apply to a material. Another is tension. Compression, tension, and shear, actually shearing. And so that's 3 of them. The other ones are less important to you at this stage, but that's bending, torsion, and fatigue are the last 3. I'll go ahead and write them down here just for the sake of being inclusive. Torsion, or twisting, if you will. Torsion and fatigue. So those are the 6 varieties. So 1, 2, and 3 here, pretty important in geology. Number 4, 5, and 6, also important in geology, but not to this class. So we're going to talk a little bit about compression. We're going to talk a little bit about tension here. Primarily these 2, but a little bit about shear as well. So Why do we talk about this in geology? It sounds a lot like physics, right? Because of this, the strain right here. In geology, we wind up having folds due to compression, or we can have faults that are due to compression. And we can also have faults that are due to tension. And we can also have faults that are due to shear. So these are the three important ones for us in this course. So we're going to talk about faults and folding next. And that's what rock deformation is all about. So I'll present the PowerPoint presentation audio lecture next. All right, talk to you in a bit.